Alright, silly people, here's the situation. We're just going to be doing a bunch of delta function integrals. Um, if you have an integral which involves a function of x and a delta function x minus a, uh, then what that integral will look like is it will set all of the x values in the function of x to a, and then the integral of the direct delta by itself is just going to end up being 1 as long as a is within the integration bounds. And if it's between minus infinity to infinity, then yeah, it's definitely in the integration bounds. So the first example that Griffiths tells us to look at is the integral from minus 3 to 1 of x cubed minus 3x squared plus 2x minus 1 times the delta function x plus 2. And now 2 is inside of the integration bounds. I mean, minus 2 is inside of the integration bounds. So effectively, we're just going to set all of these x values to minus 2. And that's squared. And then we get minus 8 minus 12 minus 4 minus 1, which is minus 25. The next one that Griffiths had us look at was the integral of 0 to infinity of cosine 3x plus 2 times the delta function x minus pi dx. And let me write that better. Pi is definitely in between 0 and infinity, so we can just say that this is going to be cosine 3 pi plus 2, and we know that cosine 3 pi is just minus 1, so we get 1 for this integral. Finally, Griffiths says, let's look at the integral of e to the mod x plus 3 from minus 1 to 1 times the delta integral, or delta function x minus 2, right? Now 2 is not in between minus 1 and 1. 2 is outside of the integration bounds. So this integral is actually 0. And yeah, there you go.